No. So today we will start with the last chapter for this semester, and that's about image formation. Okay. So when do we have an image formation? It happens if we have mirrors. There are three types of mirrors that we will be dealing with. This is a flat mirror. We will show it like this. A concave mirror, we will represent it like this, and a convex mirror that we represent like this. General information. An object is represented by an arrow AB. So if we say there is an object AB placed in front of a mirror, so we represent it by AB. The image, we will represent it by A prime, B prime. Okay, so the image, we will represent it by A prime, B prime. So for example, here, we have a mirror. We have an object AB far from the mirror by a distance P. The image is formed behind the mirror with a distance Q, and it is A prime, B prime. Okay, the distance object P, it is the distance between the mirror and the object. So when we say the distance object, it is the distance between the mirror and the object, and we represent it by P. P is always positive. Okay, P is always positive. That is, the object is in front of the mirror. Now, the distance image is the distance between the mirror and the image, and we represent it by Q. The image can either be in front of the mirror or behind the mirror. If it is in front of the mirror, then we represent it by Q positive. If it is behind the mirror, then we say Q is negative. Okay, real and virtual image. If the image is formed in front of the mirror, so like in this example, this is the object, this is the mirror, and the image is in front of the mirror, then we say the image is real. If it is behind the mirror, that is Q is negative, then we say it is virtual. Okay. Now, what is erect and inverted image? An erect image is one, it is, for example, this is the object AB, and A prime, B prime is also up. So it is erect or upright. Okay. However, if I have the object inverted, then we say it is inverted image, like in this case. Stretched or reduced. So the image can be stretched, like in this case, A prime, B prime is higher than AB, or H prime is bigger than H. Then we say it is stretched, or it is reduced. That is, H prime is less than H in absolute value. So we say it is reduced. It can also be equal. Okay, neither stretched nor reduced. It can be equal. So these are general information. Now let's start with the flat mirror, which is the easiest case. There are two cases for the rays. In this case, for example, this is a flat mirror. We represent it by FM. Okay, if the incident angle is 0, that is normal to the mirror, then the reflected beam also has angle 0, like in this case. It goes and comes back on the same line. However, if the incident angle, if the ray incident to the mirror makes an angle theta with the normal, then the reflected angle is also theta. And this is the case we studied in chapter 35. So if the incident makes an angle theta, then it reflects with the same angle theta. Now, image through flat mirrors. Let's assume I have an object AB, okay, and I want to find its image with respect to a flat mirror. What we do is that we send two rays. We send two rays from point B. One that is with angle 0, okay, and we know that it will be reflected with an angle 0. So this is ray 1, and the red light, the red one is the reflection, okay? And we send another one making an angle theta that will be reflected with an angle theta. And now these two rays, where do they meet? So this red one and this red one, where do they meet? They meet at this point here. If we extend them, they meet at this point here. Then this is point B prime and this is A prime. So this is now the image A prime, B prime. Notice that from the figure, the image is virtual because it is behind the mirror. That is, Q is negative. It is erect, that is, it is upright, and it is the same size as AB. So if AB is a 3, A prime, B prime is a 3. When you draw these things, you draw them exactly. So you use a mirror. you use a ruler. And here, if this AB is 1, 2, 3, 4 away from the mirror, we got the image to be 1, 2, 3, 4 away from the mirror. That is, in this case, P equal to Q. But remember that Q is negative, so P is equal minus Q. So this is image through flat mirrors. Now, spherical mirrors are concave and convex mirrors. What are concave and convex mirrors? They are part of a sphere of radius r. This part over here is concave, is convex. This part over here is concave. Any concave or convex mirror has a focal point. Okay, it has a focal point. So for example, if we take this dish over here, which is concave, okay, and we bring many rays parallel to each other, okay, so all rays parallel to the optical axis. The optical axis is what we see here. It is from the middle, and we draw a line passing through the center. Okay, so this is the optical axis. Now, if we draw many rays parallel to the optical axis, this one will be reflected with this, like this. This one will be reflected like this. This one will be back like this. This one will be reflected like this. This one will be reflected like this. This point over here, where all these rays meet, is called the focal point F. Okay, it is called the focal point F. So in case of a concave mirror, remember that it is part of a sphere, okay, where C is the center of the sphere. F is in equal R over 2, because this is the center of the sphere. So this distance here is R. Okay, this distance here is R. F is in the middle of R, so it is at R over 2. This is in case of the convex mirror. Concave mirror. In case of the convex mirror, so this is the convex mirror, it is the same thing. So this is the center over here, and F is exactly in the middle, but here you have to see that this is the convex mirror, everything comes from this side. Okay, so the rays come from this side. So this distance here is negative. Okay, so it is minus R over 2. O, the center of the mirror, it is called the optical center, and C is the center of the big circle or the big sphere that make this concave and convex mirror. So these are general information. Now, how does the light behave on a concave mirror? So we will focus on 4 cases here. So we have a concave mirror that has a center. So this is the center of the sphere. In all cases, there is C. This is O. O is the optical center, remember? And there is F, where it is at R over 2. Okay? The first case, if the incident ray is parallel to the optical axis CO, then it will be reflected passing through F. Okay, so it will be reflected passing through F. If it is passing through F, it will be reflected parallel to the optical case. So just opposite, these 2 cases are opposite to each other. Again, if it is parallel to optical axis, it will be reflected passing through F. If it is passing through F, it will be reflected parallel to the optical axis. Now, if it is incident passing through C, it will be reflected passing through C. And if it is incident directly to point O, it will be reflected with the same angle theta, like in the case of a flat mirror. So these are the 4 cases in a concave mirror. Now, for a convex mirror, remember that we have all the optical centers. C is in the center of the sphere, and F is at minus R over 2. What are the 4 cases? Similarly, there is parallel to the optical axis. It will be reflected as if it comes out from F. Okay. If it is as if it is going to F, it will be reflected parallel to the optical surface. If it is as if it's going to C, it will be reflected as if it is back from C. And if it is hitting at O with an angle theta, it will be reflected as if it is coming out from a mirror with an angle theta, from a flat mirror with angle theta. Okay. Now, the image formation. So this is, we are just dealing with rays. Now, if we have an image, how will it be formed based on these cases? So there are two ways to find how the image will be formed. It's either we use rays, that is, we use geometry, okay, so it will be based on the light rays, or we use calculations, and these are the rules. 1 over P, P is where the image is, plus 1 over Q, Q is where the image, P is where the object is, Q is where the image will be, is equal to 1 over F. F is the focal distance, which is either R over 2 or minus R over 2, based if it is concave or convex mirror. M, which is the ratio of H prime over H. H prime is how big is the image compared to the object. This is also equal to minus Q over P. And we call it the magnification. If it is positive, then the image is erect. If it is negative, the image is inverted. If it is less than 1, then the image is reduced. If it is bigger than 1, then the image is stretched. Let's start with the concave mirror. There are 5 cases for the concave mirror. However, for the convex mirror, there is only 1 case. For the case of the concave mirror, case 1, if P is bigger than R, R is this distance over here from O to C. Okay, this is R. So P is bigger than R. It is located here. It is after C, so it is bigger than R. This is case 1. Case 2, if the image is at R, that is at C. Case 3, if it is between C and F. So P is between R over 2 and R. This is R and this is R over 2. Or case 4, if it is at F, that is P is equal R over 2. P is less than R over 2 is case 5. Let's start case by case. So the first case is P bigger than R. So in this case, for example, assume R equal 8. This is the case over here, R equal 8. R equal 8 implies C is far from the mirror by 8 points. 1, 2, 3, 4, 5, 6, 7, 8. So R is 8. P is 12. So I have to go another 4 points. 1, 2, 3, 4. So this is where the image is, and H is a 3. So this is H is a 3. So this is what I draw. First, you draw the mirror. Then you draw this optical axis. Then you choose point C, where it is at R, so it is at 8. Then P is at 12, so I draw P. Then its height is a 3. I use my ruler and I draw R. And I know where F is because it is in the middle between O and C, so this is F. Okay, now we need to find Q, that is where is the image, and H prime, that is the height of the image, and M, that is the magnification factor, using Gray's diagram and calculation. If we want to use calculation, this is the easier part here. We start with 1 over P plus 1 over Q equal 1 over F. That is 1 over 12 plus 1 over Q equal 1 over 4. That is, we will get Q is 6 centimeter. Since it is positive, implies it is real. Okay, so the first information, it is real. Then I do the magnification factor. M is minus Q over P. It is minus half. Since it is negative, implies it's inverted. And since it is less than 1, implies it is reduced. And to know exactly how much is H prime, we use M equal H prime over H. M is minus 1.5. H prime is my unknown. H is a 3, so I get H prime is 1.5 minus 1.5 centimeter. That is 1.5 centimeter inverted. So by calculation, we use these 2 rules and I solve it. Now we want to do it by rays. So this is my object AB. Okay. Here we are free to send as much rays as we want. The easiest way is to send 2 rays, one parallel to the optical axis. So this is ray 1 over here. We know that it will be reflected as if it passing through F. So this is the first ray over here. Then we can send another one passing through F. Okay, I'm gonna send another one passing through F. If I send it passing through F, it will be reflected parallel to the optical axis. Where do these 2 rays meet? They meet here. So this is B prime. Now I see where is A prime, B prime. I do the math. It is 1.5 centimeter. The H prime is 1.5 centimeter negative. Q is how far it is from the mirror? 1, 2, 3, 4, 5, 6. So Q equals 6 centimeter. The image is real because it is in front of the mirror. The image is reduced because H prime is less than H. I can see it is smaller than H, and it is inverted. So all the information we get by calculation, we can get also by solving rays. This is not these rays I drew are not the only possibilities. I can also send a ray which is making angle theta. It will be reflected making angle theta. It will also meet at this point. I can send a ray passing through C. It will be reflected passing through C. It will also meet at this point. So I have 4 possibilities. But what I drew here is 2 possibilities. You are free to choose whatever possibilities you want. So this is the first case. 1P is bigger than R. The second case, 1P is equal to R. Okay, so the object is placed exactly at point C. Let's do it by rays first, and then we do the calculations, because now we know the calculations, how it is worked. So the image, this is the object. I will send 2 rays again. One is parallel. One is parallel to the optical axis. It will be reflected passing through F, okay? And one is passing through F, or let's put it in another color. One is passing through F. It will be reflected parallel to the optical axis. Where do these 2 rays meet? The reflected rays, they meet here. So this is the object, A prime, B prime. If I look at it, it is real because it's in front of the mirror. It is inverted because it is down. It is the same size as AB. If you draw it using a ruler, AB will be equal to A prime, B prime. And since it is inverted, then M is negative. And since it is same size, that is H prime equal H, then M is equal to -1. And how much is Q? It is equal to P because it is at the same distance. Now, using the rays, using calculation, F is R over 2. This is a concave mirror, so it is 5 centimeter. 1 over P plus 1 over Q equal 1 over F. I put 1 over 10 plus 1 over Q equal 1 over 5. I will get Q is 10 centimeter. Because it is positive, then it is real. Then M is minus Q over P. I get M is -1, so it is inverted. And same size, because H prime over H is 1 in this case. Okay, so H prime, we will get it to be -10. Let's do the third case. The third case, if I place the object between F and C, that is P is between R and R over 2. Okay, so this is my object AB. Notice here, again, I will draw the rays. So I will draw 1 ray parallel. It will hit and it will be reflected passing through F. And I will draw the other ray passing through F. It will hit and it will be parallel. Okay, let me draw this properly. Passing through F, okay? And the other one passing through F, it will hit and be reflected parallel to the optical axis. Where do they meet? They meet here. Notice that it is also real because it's in front of the mirror. It is inverted. The B prime is down. It is stretched in this case. AB is smaller than A prime, B prime. Q, if I just count, in this P is 7.5. So the first thing we do is we draw A at 7.5. R is 10, so C away from O by 10, and H is 2 centimeter. We draw the rays. Now, where is Q? It is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we got Q equal 15. And H prime, it is 1, 2, 3, 4. So H prime equal -4. If we want to do the calculations, we apply 1 over P plus 1 over Q equal 1 over F. We get Q to be 15 centimeter. Because it's positive, it is real. M is minus Q over P, it is -2. So it is bigger than 1, so it is a stretch. It is negative, implies it's inverted. And H prime is equal M times H. So we get H prime, the image is -4. So this is exactly the things we got over here by just looking at the rays. Let's take case 4. Case 4, P is at F, okay? So let's take the case that P equal 5. So this is my mirror and I draw it at 1, 2, 3, 4, 5. R is 10. So C as at 10, okay? And the image is 2 centimeter long. Now I want to draw the rays. The first ray I will draw parallel to the optical axis. Okay, it will be direct, it will be reflected passing through F. Here I cannot draw one passing through F because it is above F. So I have to choose another type of ray. I will choose a ray incident on the mirror. Okay, it will be reflected by the same angle theta. Now look at these two rays. These two rays are parallel. They will never meet. Because they will never meet implies there will never be an image. The image will be formed at infinity. There is no intersection. Notice if I solve it using 1 over P plus 1 over Q equal 1 over F, where F is 5 centimeter, I will have 1 over Q equal 1 over 5 minus 1 over 5, and that's 0. So Q tends to infinity, so there is no image. And now we do the last case, case number 5, where the object is between R over 2 and 0. So the object is between R over 2. R over 2 is where F is, and 0. So here we will take the image at 2.5. Okay, so it is between R over 2 and 0. H is 2 centimeter and R is 10 centimeter. That is, F is at 5 centimeter. Okay, now this is my image. This is, sorry, the object. I want to draw the image. Again, I will take two rays. I will take one, always take the first one parallel to the mirror, then it will be reflected passing through F. And then I have to take the second one. Also, I cannot take one passing through F because F is behind. So I have to take one which is incident by an angle theta. It will be reflected by an angle theta. Now, where do this ray and this ray meet? They meet at this point over here. Okay, so I have to extend this ray, and they will meet over here. Notice that in this case, the image is virtual. It is behind the mirror. It is stretched because it is longer than the object, and it is erect. It is upright. And if I want to calculate Q, I just count 1, 2, 3, 4, 5. So Q is equal -5 because it is behind. And H prime is 1, 2, 3, 4. So it is 4 centimeter. Now, if I apply 1 over P plus 1 over Q equal 1 over F, where F is 5 centimeter, I will get Q equal -5 centimeter. It is negative, so it's virtual. M is minus Q over P, so it's a +2, implies it is positive, implies it is erect. It is bigger than 1, so it is stretched, okay? And finally, H prime is M times H, so it is 2 times 2, it is 4 centimeter. So these are the 4 cases, the 5 cases in the case of concave mirror. Now, the case of the convex mirror, there is only one case. And this case is, so this is my convex mirror, and there is only one case. That is, if I place here, the F is at -R over 2, okay, because it is inside. And I will be placing my object, for example, at P equal 5. So it is at 1, 2, 3, 4, 5. R equal 10. That is, F is at 1, 2, 3, 4, 5. Okay. And H equal 3. That is the height of the image of the object is 3 centimeter. To draw its image, I will draw 2 rays. Okay. I will draw 2 rays. One is parallel to the optical axis. It will be reflected as if it is passing through F, okay? And the other one, I will, as if it is going to F, as if it is going to F, it will be reflected as if it is going to F, it will be reflected parallel to the optical axis. Now, where do these two rays meet? This one and this one, they meet at this point here. So this one and this one, where do they meet? They meet at this point over here. So notice that I have A prime, B prime, the image, it is reduced in size, it is erect, that is upright, it is virtual because it is behind the mirror. Q is 2.5, so it is minus 2.5 centimeter, and the height, it is 1.5, so H prime is 1.5 centimeter. And if I want to apply the rules, F, I have to pay attention that F is minus R over 2 because it is convex mirror. F is minus R over 2, so it is minus 5. Then I get Q is minus 2.5 centimeter because it's negative, implies it's virtual. M is minus Q over P, so it is half. Since it is positive, implies it is erect. Since it is less than 1, then it is reduced. And H prime is M times H, that is half times 3, and it is 1.5 centimeter. And these are all the cases that we will cover in this chapter. On Thursday, I will be solving 2 more exercises, and this will be the end of this chapter. Okay, so till then, bye-bye.